In this video, I'm going to go over AP Precalculus topic 310, which is about trigonometric equations and inequalities. So first we kind of want to investigate what makes a trig function kind of unlike other trig equations, different than other equations that we're kind of used to. Now, a lot of the algebra is exactly what we've been seeing. So if I'm talking about the equation 2 sine x plus 1 equals 0, Algebra 1 style, we're going to subtract 1 from both sides. Then we're going to divide by 2. Okay, now at this step, you can do the sine inverse, but I'm not going to do that because what this equation is saying is where is sine of x equal to negative 1/2? So I'm going to talk about a couple different cases. First case, on our unit circle. Or really between 0 and 2 pi, my y values are negative 1/2, here and here where I have my short y, which would be at 7 pi over 6 or 11 pi over 6. Okay, if I did say what is the sine inverse of negative 1/2, well, now we're talking about a restricted range from our last unit, and we're looking for where is it here between negative pi over 2 and pi over 2. So that would give me an answer of negative pi over 6. If I graph sine, and I say, well, where are we equal to negative 1/2? Well, we know this graph keeps going on forever and ever. So there's actually an infinite number. So what answer do we want? Well, it really goes back to what we're using it for. For our purposes, we're going to need to be told. Do you want all values? That would be all of these ones. Do you want principal values, which is going to be your function values? Or do we want between a specific range from like 0 to 2 pi? So if we're told a specific range, that makes things easy. If it's all values, essentially what we'll do is we'll find the values between 0 and 2 pi using our unit circle, and then add 2 pi k to each, where k is an integer, because that's going to get me this solution and this solution. And then if I subtract 2 pi, we'll get this, subtract 2 pi to get this, add, we'll get all the other ones. So that'll gather all of those up. That'll be true for both sine and cosine for all real values. All real values for tangent, the period for tangent is only 1 pi. So we'll find it between negative pi over 2 and pi over 2 using the unit circle, and then add pi k to each since our period is pi. Principal values, those are the ones where we're looking on the specific intervals. So for sine, it's from negative pi over 2 to pi over 2. Cosine's the top of our unit circle between 0 and pi, and tangent is between negative pi over 2 and pi over 2. So bottom line, you'll be told, and then you'll go from there. All right, so I want to solve this equation. So again, treat cosine x like you would an x, and then we'll handle the cosine bit of it at the end. So I'm going to subtract 3 cosine, which will make this a 2 cosine x, and then we'll divide by 3. Without a unit circle, or without our known values, there's really not a lot. You're pretty restricted on what your equations are going to end up with. Here we're saying where is our x values equal to root 3 over 2, and if you need to draw yourself a little sketch to figure that out, that's where our long x, which is going to occur here and here, for all values. So I'm going to pick my 2 unit circle values, which is pi over 6 and 11 pi over 6. And then I'm going to add 2 pi k, where k is an integer. Okay. Here, again, I'm going to treat tangent like it's its own squared. I'm going to add 4, so negative 3 plus 4 is 1. So tangent squared is 1 over 3. And then I'm going to take the square root, because this notation, in case you weren't aware, when we have tangent squared x, that is specific notation for tangent of x squared. So I'm going to take the square root, but when I take the square root, we're going to have plus or minus square root of 1/3, which would be plus or minus 1 over root 3, or if you prefer, plus or minus root 3 over 3. So that's going to occur at 4 locations, but we want the ones between negative pi over 2 and pi over 2. Or really, if you just have two, well, let's just go negative pi over 2. Okay, so that's going to be here and here. This would be positive root 3 over 3. This is negative root 3 over 3. So this is going to be pi over 6 and 11 pi over 6. Actually, well, you can do 11 pi over 6 or negative pi over 6. That will give you the same thing. And then we'll add pi k to both of those. Okay, but we could, like I said, find just 11 pi over 6 and replace that with negative pi over 6. Those would be equivalent and would still get all of our values. For principal values, this is our function values. So for sine, that's between negative pi over 2 and pi over 2 inclusive. For cosine, that's between 0 and pi inclusive. For tangent, that's negative pi over 2 to pi over 2 non-inclusive. So we're going to solve this. Now we want to be careful. It may be tempting to take this equation and just divide by cosine, but if we do that, we're actually eliminating answers. So what I'm actually going to do is subtract this over. Okay, and then we do our favorite thing, which is to factor. We're going to factor out our common factor, which is a cosine, which leaves me with a 2 sine x minus root 3. Okay, so zero product rule, whether it's a polynomial or trig functions, if I'm multiplying two things to equal 0, either of them can give me that 0. So the solutions to our cosine of x equals 0 is solutions, and when 2 sine x minus root 3 equals 0 are solutions. Okay, so this one I'll add root 3 over and then divide by 2. Okay, we're doing just principal values. So these are the values for cosine between 0 and pi, which is going to be at pi over 2. Okay, the one value between negative pi over 2 and pi over 2, where our long y is root 3 over 2, is going to be at pi over 3. All right, speaking of factoring, we can factor this as 2 sine and a sine. And you've got different methods for factoring, and they all work even if there's trig functions there. But if this is a 2 sine squared, then my two leading terms here in our binomials would be a 2 sine and a 1 sine. This has got to be a 1 and a negative 1. To get this middle term to be positive, I'm going to multiply the 2 by the positive 1, and I'm going to multiply the 1 sine times a negative 1. If you're not sure, factoring is so easy to check because you can just FOIL. I'd get 2 sine squared plus 2 sine minus 1. So then we'll separate these. I'm going to go ahead and do 2 algebra steps in one here. I'm going to add the 1 and then divide by 2. Okay, so we're looking for our y values, principal values. Y is sine at x equals pi over 6. sine is -1 at -π/2. That's for principal values. Okay. Lastly, we're going to solve on the interval 0 to 2π. Now notice that 0 is included, 2π is not. So if we're at that 0, we'll include 0 but not 2π. So we've got another factoring here. Okay, same with the last one. If this is a 2 cosine squared, my only options are that. To get a 2, I have a 1 and a 2. 2 is going to go here, 1 is going to go here. So to get a +3, we're going to make this a plus and a minus, because that'll give me 4 minus 1 when I FOIL. So 2 cosine x minus 1 equals 0, or cosine x plus 2 equals 0. Cosine x equals 1/2, or cosine of x equals -2. Okay, so we're looking for between 0 and 2π, which means we're going to find two solutions, two x values, where my x is 1/2. That's going to be up at π/3, and down at 5π/3. And of course, you can draw yourself a picture to help you out with these. Cosine x equals -2. Well, bad news, cosine is never -2. The lowest cosine is ever is -1. Okay, we're going to factor here. So either cosine of x equals 0, or tangent x minus 1 equals 0. Okay, cosine being 0 between 0 and 2π is going to occur at π/2 and 3π/2. Tangent equaling 1 is going to occur at π/4, and then again in the third quadrant at 5π/4, because we had a negative over a negative here. But we have an issue. Tangent. Tangent is not always undefined, and even by saying this statement, cosine equals 0, that should have been a dead end right there, because if cosine is 0, tangent is automatically undefined. So even though these were sort of solutions for this original given equation, if I plug in those, we're going to get undefined. These inequalities are really going to depend on your understanding of really what that unit circle looks like. So we're going to solve the inequality on the interval 0 to π, again including 0 but not including 2π. So if we're asking for sine of x to be greater than 1/2, I'm going to picture my unit circle. Okay, sine is equal to 1/2. My y value is 1/2. Here at π/6, and over here at 5π/6. Well, what this is saying is I want those y values to be greater than 1/2. Well, that's going to be everywhere up here, including these endpoints, since this is a greater than or equal to. So this one's going to give me from π/6 less than or equal to x is less than or equal to 5π/6. This x being the x in the equation, not the x on my unit circle. Okay, next we're going to figure out when cosine of x is greater than √3/2. Draw my diagram. Okay, x equals -√3/2. So that's actually those same locations. Actually, no. Sorry. π/6 is the same. 7π/6 is not. Okay, well, where my x values are greater is everything to the right of those points. And this is not going to include the 5π/6 or the 7π/6 because this is non-inclusive. Okay, but I can't just say from 5π/6 to 7π/6 because that would be this segment here. So how I need to state this, thinking as a number line, is we're going from 0 to 5π/6. Okay, 0 is included in my domain, so 0 is going to get included here. And then we're going to jump over this gap and start again at 7 pi over 6, non-inclusive, all the way to the end of the circle, which is at 2 pi, which we will not be including. If this was inclusive, then we would include it, but it's non-inclusive, so that's our solution. Next, if f of x is 2 sine x plus 5 and g of x is 4, what are all the values in the interval 0 to 2 pi inclusive, where f is less than g? So I'm just going to make that inequality. 2 sine x plus 5 is less than 4. Solve using our rules for inequalities. I can subtract 5 and divide by 2. I'm going to consult my unit circle. Okay, our y values are negative 1/2 here at 7 pi over 6 and at 11 pi over 6. And we want when x, or my sine of x is less. So we want our y values to be smaller than that, which is going to be from 7 pi over 6 non-inclusive to 11 pi over 6. Next, what are all the values negative pi to pi for which 2 cosine theta is greater than root 2 and 2 sine theta is greater than 1? Well, the two inequalities solved are saying where is cosine of theta less than root 2 over 2 and where is sine of theta greater than 1/2. Cool, let's make a picture. So first we're going to look at cosine being less than root 2 over 2. So here, cosine, mark this in purple, root 2 over 2 is going to be here, and my x-coordinate is here. This is pi over 4. Between negative pi and pi, this is going to be a negative pi over 4. And we want it to be less. So that's going to be all of these values. Okay, so from pi over 4 to pi, and from negative pi over 4 to negative pi. Then we're going to bring in sine being greater than 1/2. Sine is going to be greater than 1/2. Well, it's going to be equal 1/2 here at pi over 6 and at 5 pi over 6. Greater is going to be above. Our y values are going to be above. So the overlap, our solution to our problem, is from pi over 4 to 5 pi over 6. So that was trigonometric equations and inequalities. Thank you for watching.